Hi everybody, in this video we will be discussing about how to destroy a list in C++. So what is destroying a list is particularly linked list. When we are going to get the memory dynamically allocated, it is our responsibility to give back the memory after usage. So the concept that we may have to use is logically, this is how a circular linked list looks when there are 5 nodes. And when I want to make the deletion, I can delete the first node. But the point I have to remember is each time I should change the next part of the last node also, since it has to maintain the property of circularity, right? So I have to change like this. After I remove one more node, I should change the address of last node to the third node, and then the second node, and then the first node, and then I have to make it null. This is the concept I have to do. But see, the list is going to be destroyed entirely. Now this is the point of destruction, so let us not keep the burden of changing the next part of the last node every time. Instead, what I am going to do is I will just make it as a single linked list, normal single linked list without the address of the first node in the last node's next part. Okay, I am going to make it as a normal single linked list, and I am going to perform the deletion as I did for single linked list. Okay. So to make it as a normal single linked list, initialize temp to head, move temp to the last node, and make next part of the last node as null. Now at this point it is a normal single linked list. And what I am going to do, while head next not equal to null, we are going to repeat step number 4 and 5. In step number 4, we initialize a pointer to head, right? That is temp, you will make it to head, and you will be moving head to the next node, delete temp, right? And after we come outside, we have to delete temp and make head as null. This is to remove the last node, okay, because we stop as soon as we reach the last node. This is the idea we are going to use, and we are going to implement in C++. Let's declare in C++, the destructor will take care of the destroying. So temp equal to head, move temp to the last node, while temp next not equal to head. This is the condition for reaching the last node when it is in circular form, right? We have to tell temp equal to temp next. After that, while we are not in the last node, so while head next not equal to null, we have to repeat step number 4 and 5. So in step number 4, let's tell temp equal to head and move head to the next node, okay, and this is what we will be doing each time. And also we have to delete temp here, right? So when we come outside, how it will be, the head will be at the last node, there will be only one node and head will be pointing that, and temp is already having the address of already removed node, so I have to make temp equal to head here, right? After this we have to tell delete temp, okay, delete temp we have to tell, and we have to make head as null, right? Head equal to null. Since this is going to be automatically called in the destructor when the list goes out of the scope, we will not be able to check this explicitly. We can check if we want by putting inside braces, but I'm not going to check that now. I will just check whether the code is working properly or not, right? So let us compile the code and check. Okay, but I think it's going on an infinite loop. Let us check the code. So destructor is called, and okay, so the problem is when I was implementing, I have reached the last node, but I haven't made the next part of the last node as null, right? So it is going on in an infinite loop. Since it's a circular linked list, it is coming to the front and going on an infinite loop. So let me make this, and also I have to make temp equal to head, I think, but I don't think so that is required. That will be automatically taken care when we are inside the loop, right? This is right, I think. So let's check it, compile it and execute it. Yeah, so the nodes will be properly removed. You can check it. The code will be shared in GitHub. Thank you.